Hi, my name is Moshe Zadka. I'm going to talk to you about how to build Python applications with Docker. Um, if you're taking notes, feel free, but you don't have to because all this talk is on the web with all the code examples. If you want to get in touch with me, cobradism.com. That's a math joke. I can explain to you later. There's about 100 people in the world that actually understand that joke. I've been using Docker in production for the last 4-ish years. So I've made a lot of mistakes. I've done a lot of things well, and hopefully I can teach you how to not make mistakes and how to do things well. So I'm gonna talk about the terms. What is container? What is Docker? I don't think a lot of people have like the nuanced understanding of exactly that. That's like my actually part of the talk. But I'm not gonna correct you. I'm gonna correct myself. So that's good. I'm gonna talk about common mistakes. Mostly I'll show you the worst Docker file in the world, but I promise you that everything I've put in there, I've seen actually done in production. And then I'm going to talk about how not to do those things and how to do the right thing. Okay, so what are containers? Basically, the best way to think of them is share less processes. That's not share less, it's share less, meaning these are processes that share less with each other. So they don't share limits, they don't share file system, they don't even share PID namespace. All of these things can be shared optionally. Docker has about 5 million options to exactly what you want to share with what. But basically, they're processes that share a lot less with each other. What's Docker? Docker is a tool to run containers, and there's a bunch of things that are all called Docker for mostly marketing purposes that are very distinct. Docker is a client. When you run Docker on the command line, you're running the Docker client, and it talks to a server. The server is usually also called Docker, but it has a proper name. When you're talking about server, maybe use the name containerd, which is the actual name of the server. And that server listens to the client, and it does a bunch of things, but sometimes it runs containers. Haha, no, it doesn't. It uses a runner, which is runc. It also has a proper name, but it also is called Docker a lot of the time. And then there's also a Docker hub, which is where you put your container images if you're happy with them and you want to share them with other people. That's also a totally separate thing. In general, you can use any registry, but Docker Hub has a bunch of special support in the client, meaning if you don't specify a registry, Docker Hub is the default registry of the Docker client. Yes. So hopefully that actually is the Docker stuff. A container image is basically a tarball. Well, actually, it's really a set of tarballs. But the set of tarballs together, if you put them together, they look a lot like Linux boot, right? If you install a Linux machine or a VM and you go to slash, there's like a certain /bin, /sbin, /lib, all the stuff, /user bin. Basically, that is almost exactly how a container image looks like. And there's also some metadata. For example, the entry point, which is what process to run at startup. So that's a container image. And what I'm going to teach you today is how to build good, ideally, container images. There's a lot of ways to build container images. You don't actually have to use a Docker file. That's my next. Like I said, this talk has a lot of actuallys. You don't actually have to use a Docker file. There's a lot of ways. Dockerfile is the most popular one. It's the one supported by the Docker client and the Docker server via a very complicated protocol they run between them out of the box. So most people will use them. It used to be kind of not a really good system, and now it's still not a good system, but now it's kind of usable to do good with. So I usually recommend people use it. It usually has these 3 parts, which is from, reading which container image we're starting from. You always have to start with something. You can start with Scratch. Scratch is an empty container image. Usually, very few people start with Scratch. You copy things from the context, which means from the things that are like right next to the Docker file. Like maybe you have some Python code, or maybe you have some images. You copy them into the image, and then you run some commands. Those commands will run in the context of the Docker container. It will basically change the image, and the result will be what is after all these copies and runs based on the from image. The title of the talk is Building Python Application with Docker. So for that, we'll have to write a Python application. I have pre-written a Python application. This is a pyramid application. I've dropped the import lines, which are not as interesting. If you haven't used pyramid, it's a lot like Flask or Django. It's a WSGI application. And to run WSGI application, of course, we use WSGI simple server, and we run it. So it's a lot of code, but it's not really interesting code. This is the kind of code you write if you're using Flask or Django or Pyramid or Bottle or any of the 5 million other WSGI frameworks. Okay. So here's an example of a bad Docker file. Unfortunately, if you Google for Docker files, this is the kind of Docker file you'll find. I'll kind of go over it a little bit to explain what it does. And the real problem with this Docker file is it works. If you actually build it and you kind of like do Docker run with the right parameters, it will run your application. And you will test it and it will look like everything is going fine. And then when you actually put it in production, you'll have a lot of fun. And I'll talk about the kind of fun you'll have in production and why you want to avoid that particular fun. So it starts from Debian latest. That's very common. Sometimes you'll see CentOS latest. Sometimes you'll see Alpine latest. I like Debian, so I'll use the Debian as an example. Then it's get updates because clearly like you got something that's latest, but it doesn't have the latest Debian stuff. And then you install Python 3 and Python 3 pip. Hopefully you all use Python 3. If you're using Python 2, you probably want to think about using Python 3. Then you install Pyramid because, as I said, you need to install the WSGI thing. Then you copy. I've been talking too much about that. Then you copy your Python code. As I said, copy is the main command that you use to copy things that you already have into your Docker image. So you copy the Python code. Then you set the Python path so that you'll find the Python code. And then you run Python 3 -m catx. So -m will run your under domain, which runs your make server with your application. So if you actually do that, it will give you an application that runs, that has, that it will display what you want, and everything looks good, and you're all done, and like, I guess I finished my talk way shorter. So what's bad about that? Use latest. What's latest? Tomorrow's latest is different than today's latest, because that's how like time works. No, but it's important. Like, if you do it tomorrow, you'll get a different image, right? That's not good because then you'll like fix a bug, you'll run it tomorrow, and then you won't actually get the bug fixed. Also, like a bunch of new Debian packages. That's going to be really fun to debug in production. What's changed? There's a lot of layers. Like I said, like a container is really a collection of tarbles, not one tarball. Every single line in the Docker file is a layer. The more layers you have, the longer the startup time, the more complicated the Docker runtime is. So layer explosion is when you have a lot of lines, meaning you have a lot of layers in your Docker file. Startup and like file lookup are going to be slower. That's not good. So it'll be slightly slower in production and slightly slower to start up. That's especially not fun when you're deploying it across like 100 machines, and every startup takes a lot of time because you want to slow deploy and slow rollout. But you don't want really, really slow rollout, just on slow rollout. It installs random system packages, right? Which version of Python 3 am I installing? I don't know. Which version of Python 3 pip? Probably something is worse, I don't know. Then random Python packages, right? I did pip3 install Twisted and Pyramid. Sorry, just Pyramid this time. I'll install Twisted later. Anyway, I did pip install Pyramid. What version of Pyramid I'm getting? So you might say, oh, I know how to fix that. I'll do pip install Pyramid equals some version. What about its dependencies? I don't know. Some dependencies changes, and suddenly it breaks. Well, I guess breaks in production. Fun, huh? Yeah, so like I said, like there's a lot of fun involved in this. But only when you put it in production, because when you test, it'll work, right? Because like by definition, until it doesn't work, you'll fix things. Like, okay, that's the version. Then it sets Python path. You never want to set Python path. And the reason is because there's always something weird that happens when you set Python path. It'll always like change the search path in a way that you don't expect. And when you try to debug something, it will always like hurt you in the worst possible moment. I have a whole blog post about what's wrong with Python path. I don't want to delve into that. There's a lot of details, but you can Google for my blog post. And you're shipping the build environment. In this case, it's not that bad because luckily none of our dependencies have C things. But if any of our dependencies had C things, now you had to install GCC and a lot of things, and then I ship those into production, probably in a way that will make an exploit that wasn't a vulnerability that wasn't exploitable. Right, you want to ship the minimum amount into production so that if you have a vulnerability, and let's be fair, it's like when you have a vulnerability, it's harder to actually build the vulnerability into a working exploit. So you have some time between seeing that people are trying to poke your stuff to actually fixing your vulnerability. And it's using the reference WSGI server. The reference WSGI server is literally the thing in my nightmare. Because it says on it, don't use it in production ever, but nobody ever reads that part, right? Literally, the mind skips over, the little, it's actually not easy to see, it's in this weird font of white on gray that's really, really easy to ignore in the official documentation, and they skip it, how to use it, and then it works. But not in production, right? It's one thread, one process, so as soon as you get contention, guess how well you're using your CPU? The answer is not well. Not well is the answer. Okay, so I would love to say that this is an example I made for this talk. This is an example I made for this talk. Every single one of these problems I have seen in production stuff. So basically all this talk is about how to avoid this list of problems that unfortunately is if you Google for how do I, you'll see all of these things happen. So just like building a house, you want to choose a solid foundation. If you don't choose a solid foundation that is stable, your whole thing will break. You can start playing games with adding versions. That never works because the weird thing about pretty much every container registry, it will have a garbage collection scheme. So that means if your container isn't pointed to by an official name, it will eventually get garbage collected. It's slightly better to have your build process fail than to succeed with random inputs, but it's even better to have it not fail, right? That's the ultimate. And the best thing to do is to just prevent the garbage collection by adding a pointer, right? That's how you prevent garbage being collected. So basically, the way that I haven't found an official name for it, so I call it fork tagging. Fork tagging means I'm not actually forking. I'm using the same image, but I'm just giving it my own name under my own namespace. And the thing is that in Docker, there's literally facilities to do that. That's pretty awesome. I don't think a lot of people know about it. Here's basically a script to do that, right? So I'm taking PyPy and I'm using 3slim. Basically, 3slim is as bad as latest, right? Every time PyPy releases a version, which happens every month or so, they'll update PyPy 3slim. Next month, I'll get a new PyPy. Probably with some fixes, probably also with some potential regressions that I don't want to find when I'm rebuilding. So I'm tagging it with datetime now, which I think goes all the way up to the microsecond level. So it's very unlikely you get a collision. And then I'm basically doing pull tag push. Now the way Docker registries work is actually very funny. They know how to not write things when they don't write. They kind of actually have a hash name for each thing. So the pull will actually take some time. The push will be almost instantaneous. It can be 100 megabyte image. The push will still be almost instantaneous because it just says, oh, I only know all these hashes. Don't need to upload them again. Floop. But all it does is it makes a new pointer now with the name Moshe/PyPy3 and the date time. Now, the nice thing about time is that it keeps changing, right? And so you might think, oh, if someone wants it very fast, there might be a problem. That's not going to be ever a problem because the real problem is what happens when I build tomorrow, right? If a build has already been in production for more than 5 minutes, this will already have changed. If a build hasn't been in production for more than 1 minute, why do you care? You probably haven't tested it anyway. So it doesn't really matter. But anyway, I have literally never seen it colliding. I'm using PyPy 3 Slim. PyPy is a good Python. You should use it. PyPy 3 is pretty awesome. And the Slim image doesn't have a lot of build stuff around it. So this means my base is pretty clean. It's actually pretty small if you... you can actually go to Docker Hub and check there's like Moshe/PyPy 3 there with some, very, very long date. And you can check how big it is. It's actually not that big. Okay, yes. Okay. Oh, wow. It's faster than I thought. Okay, so you want to build a Python image. You're going to talk about how to put the Python stuff in it. There's a few different ways to build Python artifacts. You can use an sdist, which is basically just a table of sources. You can use a wheel, which is basically fully built and ready. Installation is pretty reliable. And you can use a PEX. That's one of my favorite things. It's basically a wholly contained Python executable with all the third-party dependencies. So the installation is just a copy. Unfortunately, PEX and PyPy do not work. Like there's this thing about innovation tokens that you can only do one strange thing. You'll have to choose between PyPy and PEX. Literally this time it's because they are not fully compatible. I'm pretty sure it'll get fixed in 3 or 6 months, but until then, you're going to choose one or the other. And since I chose to use my innovation token in this talk about convincing you to use PyPy 3, I will not be able to use it on PEX. Virtual environments are also basically an artifact. They are location specific, but the nice thing about Docker images is you can choose your location. You can be more civilized about them by using something called DH-virtualenv if you're on a Debian-based thing. I'm not going to be civilized, so you'll see me doing things pretty well. Then the next way to correctly build Docker images is to use multistage builds. What are multistage builds? Well, you build images sequentially, but you throw away all the images except the last. That's pretty stupid. Why build everything that... because you can copy things from the previous image, right? So you can build an image. It's going to be thrown away by the end. But until it's thrown away, it has a lot of potential artifacts in it, and you can copy it to the next image. Almost always, the multistage build is written in a way that you'll probably have 5 or 10. Unless your life has already, you've already made a lot of bad life choices, you won't need more than 2. The build container and the production container. The only time you need more than 2, if you somehow have 2 things that cannot be built on the same build container. That already means you've made a lot of bad life choices. Like you need 2 different versions of GCC because this is the one that's not compatible with this. Oh, God. So here's basically the skeleton of a typical multi-stage build. From source, it used to be that you couldn't do the S name and then you had to number them. Remembering numbers, even if it's just number 1, number 0 is horrible, so it's annoying. Do S name so it's civilized. Then you do from potentially other source. You can start, of course, from the same source. And then you can copy anything minus from name. That means do not copy it from the context where the Docker file is. Copy it from the previous image you built. And then, set the entry point accordingly. So here's a better version, right? You'll see that this name is very, very long. That's good because if I ever change it, it's a source control operation to change it. I can upgrade to a new version, but it's a source control operation, which means there's a review, there's potentially a CI, there's tests, all these nice things. Then I create a virtual environment. I install it in Twisted and Pyramid. Then I copy the code and the setup UI. So I actually install it as a Python package into that virtual environment. So I don't have to futz around with any Python passes. Then I tarball it all up, and that's going to be the thing I'm copying. Well, and then, it actually fits better now than in my tests. So I copy from --4 builder append to slash, and then I unpack it, and then I set my entry point to Twisted. So there's a bunch of nice things that happens when I set my entry point to use the Twisted WSGI container versus the WSGI entry point. A, it is a container that's meant for production, and B, and most importantly, it's also good as a PID1 because it will adopt orphans. And if you don't know what adopting orphan is, it doesn't matter, but if you don't have that, your Docker container will be very sad pretty soon. So I don't have enough time to actually show you how to how to properly do luck, but I can show you a little bit of like a taste of it. Basically, like you saw that I pip installed twisted pyramid, so I kind of YOLO that part. Unfortunately, actually showing that would make the Docker file much longer, but I will kind of give you a taste of how to do it more civilized. Basically, you have a Docker container that only knows how to do one thing, which is to transform the loose requirements to the locked requirements. Loose requirements are things like I need twisted pyramid. The locked requirements are here's all the list of dependencies with specific versions. And again, you want to do the change which versions are locked as a source control operation because people want to review them. Sure, it's just reviewing a bunch of numbers, but you can ask which unit tests have you run. Oh, I see this version of this library has changed. This library has given us problems in the past. Please make sure you run these tests, and so on. So it is a proper source control operation. Use the usual source control workflow to update the third-party packages. So basically, you have requirements.loose.txt, which in this case will just be literally the list twisted pyramid, and the entry point is lack requirements, and then you so it's kind of annoying. Python setup UI is a Python file. As those of you who took CS know, there's no way to emulate a program without actually running it. Right, that's the halting problem basically. So you basically literally have to install all the packages to figure out what the right dependencies are. But you install it in a Docker container that only does that, like literally nothing else. So you install them, then check by doing freeze -- all. For some reason, pip freeze will not give you all the frozen things. It will skip over things it thinks you don't want to actually lock. I want to lock everything, goddammit. So -- all. And then I just write it out to the std out, so that's fine. So summary, use multi-stage builds, otherwise you're shipping a build environment, that's not good. Lock your Python requirements. Don't do what I did, I just did it to kind of make the talk a little bit easier to follow. And think about your entry point. Your entry point should make sure that it's like something that's actually good to run in production. And if it's not something that knows how to do PID1, which the most important thing is to adopt orphans, then you want to run it with something like Dominate from Yelp, which will adopt the orphans from you. Who here knows what adopting orphans is? Oh, wow. Okay, so Unix processes are really, really funny. And when they die, they kind of keep like this kind of thing in the entry table that said, I died with this output. And that's so that you can wait on them. Until then, they're called zombie processes. This is actually how it's called in the, if you actually run ps -ef, you'll see z next to things. And if you have nothing whipping them, then it's bad. Now, what happens if a process dies after its parent died? Well, its parent is never going to call wait because it's already dead. So when a process dies after its parent died, it becomes, it's called an orphan process. What happens is PID1 has to adopt all the orphans and to call wait on them. Until then, they basically stick in your process table as zombie processes, which means if anything along your chain ever runs a process and somehow something is dead in the middle, which is really, really easy to do, because then you'll have a bash thing that runs the thing, and like you have no idea what like library that you're depending on, like, you know, via multistage does it. You have an orphan process. If you have nothing adopting these orphan processes, then your Docker container will be full of these zombie processes. Now, unless you're very, very careful about setting limits on your Docker container, that will actually fill the overall process table, in which case it will like completely shut down your Docker host, which is really bad. If not, then it will only kind of disable your Docker containers, which ideally will restart. So you always want to make sure Twisted knows how to adopt orphan processes. If you're not using something like Twisted, use something like Dominate from Yelp. Okay, I think I am done. So hopefully I've taught you a lot of like actuallys about Unix and Docker, and also what to do. And like I said, this talk is available on my GitHub. Cool. Let's open it for questions. Oh, sure.
So in your experience, what have you found your main limitations and pain points of using Docker are?
Repeat the question.
So what are the main limitations of using Docker? I guess it depends on what you compare it to. Docker is still a pretty immature product. It will sometimes have surprising behavior. Like Dockerfile is literally the worst language that is still usable for something, right? Literally, how do you make something where you cannot have different lines without having semantic implications, right? You can usually work around it nowadays, but be aware that if you're using Docker, you're going to have to play around a little bit because it's not really a mature platform yet. Sure, yeah.
I have a question. So I'm more interested in Docker and VMs if I want to deploy reproducible software.
Sure.
I want people to be able to reproduce it and actually make it more easy for a user to access some software that needs a lot of installations and things that are complicated.
Sure.
Like novice users. What's the easiest way for me to do if I'm a scientist creating some climate model that I want to
So most of what I've shown is pretty applicable to that case. You might not want to decide on an entry point in this case, but I'll tell. Sure. Okay. Yes. Right. So how do I deploy? How do I give people reproducible builds? So most of what I said pretty much answer this question. Like you pretty much do all of it, even if you're doing science. The only thing I would change, and I actually talked about it with Travis earlier. Let's see, where do I want to go? Here. Here. So you'll see that here I use pip to create a virtual environment and install a lot of things there. If you're heavy science stuff, you can use all of the same ideas, including locking and like all of these with Conda. And that is a pretty much like mutatis mutandis, the same Docker file, the same ideas. Install Conda in like its own kind of basically conda env and then wrap the conda env and move it to the runtime container. But this will allow, and again, like, kind of version your conda stuff so you know which version to install and so on. But this will allow you to kind of build a container image. So first of all, your container image is an artifact, right? It does go to like, say Docker Hub or Quay or one of those public Docker registries, and you can just point people at them. Again, never latest. Use something like a date tag. So when you build it, people know which version they use. So if you build a new one, they know, well, it's changed, right? So like maybe you actually fixed a bug, but then you change the graphs, right? Ideally in a way that's good, but they want to be able to know what they've done. So like latest is basically the worst thing about Docker, pretty much, right? Like never use latest. And again, like, if you, so you can give people reproducible builds. And then the entry point can even be like a shell script that outputs something, or you can have no entry point, and just so when people do Docker run, they end up in a shell that they can kind of run some tools you've written. So it depends a little bit on like exactly what you want to give people and like what's the level of sophistication of the people you want to give it to. Well, like, do they know how to use a Unix command line? No, then you probably want to like make it into a web server so they can just use Docker run and kind of see the web. There's some things to kind of think about when you use Docker run. Actually, like getting to the point where you can do a Docker run, is not completely trivial, although it's getting better and better. Like by now, you can pretty much, if you're on a Mac or a Windows, you can pretty much click a bunch of buttons, getting to the point you can use the Docker run. But the UI client is kind of meh, so they'll still have to kind of open the Windows or the Mac UI and actually do a Docker run.
Is there any way to write a Docker file that's platform independent? Or is it always tied to an OS?
Sure. So is there a way to write a Docker file that's independent, that's OS independent? So let's think about a little bit what it would mean to be OS independent, right? If you run the Docker file, by the time you run it, you have to include some base. So you can include Scratch and literally just put in the things you want. You will basically be building your own Linux distribution at this point. You'll be doing like 50% of the work you need to do a Linux distribution, and you're gonna do a bad job at it. I'm sure you're a very smart and industrious guy, but you're not as smart as like all the Debian developers combined, or whatever other OS you use. So you pretty much, you can, like some Go people tout it as a big advantage of Go that you can use from scratch and put the Go thing and doesn't have any dependencies. I guess I find it hard to believe that it's that important. The OS gives you a lot of useful things, right? Again, like if you don't need them, you can, you'll have some Debian in there, but you can install most of the things from Conda into a Conda environment, and you'll pretty much have a Conda. You can use Nix instead of Conda if you're in a Python conference, and I'm assuming you like Python. Conda is really the best kind of like meta OS for Python, so you probably want to use that. But if I was talking to a different conference, I would suggest maybe looking into Nix as well. Cool. Any other questions? Awesome, thank you.